In this video, we will talk about two electrical components of an electrical circuit whose common characteristic is to protect the electrical circuit from high current. High current may be undesirable in some cases. Basically, it can arise in two ways, either by overloading an electrical circuit or through a short circuit. A circuit can be overloaded when too many appliances are connected to it, or when appliances are connected to a single circuit that is designed for lower current flow. If appliances are connected side by side on several branches, then a very large electric current is generated on the main branch. For example, in the home, this means putting a hub with 4 outlets into one outlet to power a refrigerator, an electric kettle, a cooktop, and a microwave, and running all of these appliances at once. By doing this, we have connected too many appliances to one circuit, which consume a large amount of electricity and are therefore guaranteed to overload the circuit. The second case of a large electric current is a short circuit. Recall that a short circuit is the sudden connection of an electrical circuit without an appliance. This is a situation where two conductive parts touch, creating a new node and a shorter branch between them. It certainly has less electrical resistance, and the electric current will most often take the path of least resistance. Because of the low resistance, a very large electric current will start to flow through the conductor, and therefore the circuit will overload at that point. The conductor becomes more heated due to the high current, which can destroy the conductor by overheating, and in the worst case, overheating the conductor will cause a fire. The danger for a burnt-out conductor is therefore too high an electric current. Electrical components called fuses and circuit breakers protect us from large electric currents. If an electric current greater than a specified limit passes through a fuse or circuit breaker, then the fuse or circuit breaker will open the electrical circuit. The specified limit of current is called the rated current. Therefore, fuses and circuit breakers do not directly protect against short circuits, but against their effect, which is a large current passing through the conductor. Now let's talk about the individual components. The fuse is made of a thin metal wire that will melt if too much current flows into the circuit. When the fuse melts because of the high current, it breaks the electrical circuit and protects the other components of the circuit from damage. It is therefore a controlled burnout of a conductor in a protective enclosure that protects the surrounding area from fire. Fuses come in a variety of sizes and types. The most common type of fuse is the tubular fuse, which is made of a thin glass tube in which the fusing wire is placed. The fusible wire is made of a material that will melt at a certain large current rating. For example, if the rated current of a fuse is 10 amps and we let 8 amps into the circuit, then nothing will happen. However, if we allow an electric current of 12 amps into the circuit, the wire will burn out and the flow of electric current will stop in the circuit. The schematic mark of the fuse, then, looks as we have shown it in the figure. The mark closely resembles a thin wire in a tube. Now let us mention the advantages and disadvantages of this component in the protection against large current. The advantage of the fuse is that it is an inexpensive component and works on a simple principle. If a higher rated current is required, a fuse with a slightly thicker wire is purchased according to the value of the rated current. The disadvantage of the fuse is that it is only a disposable component, and once the wire is blown, it is not worth repairing and must be replaced with a new fuse in the circuit. The second electrical component we will discuss is the circuit breaker. It works on a slightly different principle than a fuse, but its purpose is the same. A circuit breaker is a component in an electrical circuit that protects against overload. A circuit breaker works by containing a conventional switch. If the current exceeds the rated current or a short circuit occurs, the circuit breaker automatically switches the switch from the closed position to the open position. The schematic marking of the circuit breaker, then, looks as we have shown in the figure. Just as a fuse resembled a thin wire in a tube, then a circuit breaker closely resembles a switch. Now let us mention the advantages and disadvantages of this component in the protection against large current. The advantage is that when the short circuit or the cause of the high current is removed, the switch can be closed and the circuit breaker continues to operate without having to be replaced. This is also why fuses have been replaced by circuit breakers in homes. However, circuit breakers are more expensive and have a more demanding principle. We will now describe it and show it in a few steps. The basic electrical component that opens the circuit is an electromagnet. Next, the circuit breaker contains a switch and a steel armature attached to the switch, which is closed. Therefore, an electric current can pass through the circuit breaker that is now lower than the rated current. The electromagnet starts to behave like a magnet and starts to attract the armature. However, its magnetic effects are not strong enough to attract the anchor. The moment an overload occurs, then an electric current higher than the rated current starts to flow through the circuit. The electric current will therefore increase, thus increasing the magnetic effects of the electromagnet. Now the magnet is strong enough to pull the steel anchor. Pulling the armature opens a switch in the electrical circuit and the electric current stops flowing. The electromagnet is therefore positioned so that when the rated current starts to flow through the circuit, it is already strong enough to pull the armature towards it. Pulling the armature opens a switch in the circuit and current stops passing through the circuit and circuit breaker. If the cause of the overload in the circuit is removed, the switch can be switched to the closed position and the circuit breaker can be operated again. So we've described how a circuit breaker works, but now we'll talk about where circuit breakers are found in the home. Circuit breakers in the home are usually located in the electrical panel, also known as the electrical box. Circuit breakers have different current ratings. Each electrical circuit in the home has its own circuit breaker. When an overload or short circuit occurs, the circuit breaker opens the electrical circuit and must be manually closed again. We will now move on to the individual tasks. In the first problem, we have to decide whether a circuit breaker with a rated current of 15 amperes will open an electrical circuit if the following currents flow through the circuit. So we have to decide here, is the value of the current passing through the circuit greater or less than the rated current. If the value of current is less, the circuit will not open. If the value of current is higher, the circuit will open and the current will stop flowing. The subtask is 5 amps less than the rated current of 15 amps. Therefore, the circuit breaker will not open. The same is true in case B, where 14½ amperes is less than the rated current of 15 amperes. In the case of C, 17 amperes is already higher than 15 amperes and therefore the circuit breaker will open the circuit. In the case of D, no whole 1800ths of an ampere is a very small current that is less than 15 amperes, and therefore the circuit breaker will not open the circuit. 15.5 amps is again more than 15, so it will open, and 1½ is less than 15, so again it will not open. This would have completed problem number 1, where we compared whether the amount of current going through the circuit is less than or greater than 15 amps. This completes problem number 1. In problem 2, we have a circuit breaker that is part of an electrical circuit and has a rated current of 25 amps. Our task is to decide whether the circuit breaker will open the circuit if we connect 3 appliances as shown in the diagram. In the case of yes, we have 3 appliances that consume an electric current of 11 amps, 12 amps and 4 amps. Our task is to add the current consumed and decide whether the result exceeds the rated current of 25 amps. So add the numbers 11, 12 and 4 and we get the result of 27 amps. All 3 appliances together consume 27 amps. This is more than the rated current of 25 amps. So the circuit breaker opens the electrical circuit. In case B, we have 3 appliances that consume an electric current of 8 whole 1/10 amperes, 5 whole 3/10 amperes, and 12 whole 5/10 amperes. So let's add up the numbers again, this time in decimals. 8 whole 1/10 plus 5 whole 3/10 plus 12 whole 5/10 amperes gives a total of 25 whole 9 amperes. Thus, all three appliances together consume 25.9 amperes. This is more than the rated current of 25 amps. So the circuit breaker opens the electrical circuit. In the case of C, we have three appliances that consume an electric current of no whole 90/100ths of an ampere, 3 whole 7/10ths of an ampere and 19 amperes. So let's add up the consumption of the appliances again. No whole 90/100ths of an amp plus 3 whole 7/10ths of an amp plus 19 amps gives a total of 23 whole 60/100ths of an amp. Thus, all three appliances together consume 23.61 of an ampere. This is less than the rated current of 25 amps this time. So the circuit breaker will not open the electrical circuit. What you should take away from this video is what a fuse and circuit breaker are. How these electrical components work, how they differ and what they protect us from. It's also important to know what the rated current is, which determines whether a circuit breaker or fuse will open an electrical circuit. That's all for this video. If you like the video, don't forget to support us by subscribing or liking.